So we're back. So now we're gonna go proceed with the second normal form normalization process. So we can check out the first normal form table again here. We got again course ID, course name, enrolled students, grades, and professor columns. And for each value, we got unique cells. But here we're not done. If you analyze the table, you're gonna see some redundancy, many copies, the fact that this table is not really readable and very hard to analyze. And also, if you're talking about first normal form table, this table is not flexible in case of data manipulation. If you're going to insert a data, if you want to update a data, if you want to delete a data, you will face with many anomalies. Just let's consider you want to delete a student name from the data. Let's think of Yusuf Hassanov, and he'd withdraw from the class and not anymore enrolled in the course. So in this case, if we remove the Yusuf Hassanov cell, the whole tuple will be removed, and this means the course name, obviously the course itself, is removed. And now Yusuf has gone, the course also has to have to gone. And he has grade as well, and the professor name as well, which doesn't really make sense. And to avoid this kind of anomalies, we have to apply a second normal form to our first normal form table and create very unique tables for different data types. If we're talking about second normal form, we have to memorize a few keywords, which is primary key, uh, non-attribute, non-primary key attribute, and functional dependency, and foreign keys. So here, the primary key is the very much essential part or column of the data, which is here. If we look closer carefully, course ID is the one we're talking about. Course ID defines the course name, the professor as first, then enrolled students, grades as well. But as grades is not really dependent on course ID, as grade has really nothing to do with course ID, course itself, but rather dependent on the student and linked with the student. This is the result of students. And there's nothing to do with the course itself. This table doesn't really make sense and looks redundant, looks inconsistent. We have got grades, we've got students. Okay, those are all related to course, but to analyze in such formation, in such representation, it makes it a bit hard and absurd and blurry to read the data. And for that, second normal form uh, allows you to separate the table, the given table, into many different tables, and create foreign keys, create primary keys for each table, and make them much more readable. So here, we're gonna have to separate the table in the first table. We're gonna have to generate a first table from course ID, course name, and also with the professor data, but we will be using professor ID instead of professor. Even though we don't have the professor ID information here, we can add it in add it as a foreign key to courses table. We're gonna create and make the table more readable and more flexible. So the very first table I'm gonna create is courses with course ID, course name, and professor IDs. And then we can create second table with the course name, enrolled students, and their their names and their IDs. We can create a table about students itself only. It will have also another additional additional data, which is linked to students directly. We will have student ID and student names in one separate table. Then um, professors itself, we'll also have professor ID and professor name table, which will gonna be third table. And then grades will be slightly different from the other tables, as it will have to get a composite key in order to survive. I mean, if the grade is there, it has to be. It is linked to a student, but it also has to be from a specific course. If you got a grade A, you can't just say I got a grade A, but you say I got grade A from math or biology or economics, whatever. Your grade have to be linked to your course and your student ID for more readability. So I have applied all these executions to the Excel sheet, and I'm gonna just skip those parts, which is very necessary to show you, and come to here this presentation so that you can view it in a ready form. Yeah. So as I promised, sorry, my picture is not really visible. Okay, my video recording now is visible. Okay, cool. So we've got students table here with student ID and student name. So student ID is here. Here's primary key. We got unique primary keys for student IDs, primary key for student IDs, and student name. One thing to mention, I forgot about it. That is, if you notice, if you look carefully, the tuple numbers, number of tuples, are now less than it was before in first normal form. If you look at professor ID, it will be more visible, or course ID, it will be more visible. Why this happens is that in the first normal form, there are many copies. There are many copies. You can see C003, C003, C003 from the physics course. All are taught by Nigar Rahimova, but as they are students different assigned to that course and grades assigned to that course, we have to repeat them. But here in this table, we do not have such obligation. So we just go with the unique values and no repetition, no copies needed here. Only in this table, which is very much obligatory, and we have nothing to do with it for at least in this form. So coming back to analyzing, so we got student ID, student name, creating the students table. We've got course ID, course name, professor ID. As you can see now, we have got a new column of data, professor ID, and as I have assigned just random numbers to professors, and you can view the professor ID here now and see the professor name, which is assigned to those professor ID. And then we've got the most important part, grades, which is the which does have the composite key of course ID and student ID. Oh my god! I just noticed something that there's an inconsistency here, and which is about the student IDs I have created. This table has different student IDs, but this table has different student IDs. But from now on, I don't really have much time and much thing to do. I'll just kind of skip. I'm just gonna act. It doesn't. It's not there. It's the same. It doesn't really matter anyways. But we just assign it randomly, and student IDs are assigned randomly, and consider for the harem of its consider this as main student ID. If it's 14081, here as well 14081 is belongs to Zaharamov, and Zaharamov has its her grade. So yeah, coming back here. So course ID and student ID have got um, the student ID and course ID for the grades as composite key. Those are both primary key, composite primary key. And if you want to refer to a grade that has that the student got from a course, you just have to look for the student name, then check for the student ID, then come here, find the respective student ID in this table, in case it was right, and I can't do it right now, sorry, but you find the student ID, and then for the student ID, you check for the course, and for that course ID, now you can view which course was that the student Zahra Rahimov had got A or B or whatever. And you can also check about the professor name that teaches that course from this table. Uh, I think that I've covered pretty much everything about the 2NF now. Please ignore the consistency between those two tables. I will mention it in the Word file, but now as I've already recorded pretty long video, I'm not gonna skip it and I'm not gonna re-record it. Sorry, very much sorry. In the next video, we're gonna proceed with the 3NF appliance of 3NF.